Welcome to this tutorial in which we are going to discuss yet another very famous problem called maximum product contiguous subarray. So as usual, we'll first start with the problem statement, we'll understand it, we'll look at some sample cases, and then we'll proceed with the approach or the logic to solve this problem. So the problem statement is we are given an integer array A and we need to find the contiguous subarray containing at least one number which has the largest product and return this product. So the array can contain negative as well as positive elements, and we need to return the largest product that we can get from this array, and we need to make sure that containing at least one number. So the product should be of at least one number, and this is the overall problem statement. So let's look at some sample cases to understand it better. So suppose our input array is A, which is 2, 3, minus 2, 4. So as you can see here, the output is 6. Why? Because if we take the sub array which is 2, 3, the first two elements, then the product is 6. Now let's check some more sub arrays within this array, and let's check what their product would be. So suppose we need to take at least one element, right? So the maximum product with one element we can get is 2, 3, minus 2, 4. So answer would be 4, right? Which is the single number itself. Now let's check the sub arrays with length 2. So as it has been mentioned that find the contiguous subarray. So contiguous word is very important here, so that we cannot skip any element in between. We need to take the entire contiguous set of elements without missing any element in between. So as you can see, if we take the subarrays with the length 2, so 2, 3 would be the first subarray, 3 minus 2 which will give us the product minus 6, and minus 2, 4 which will give us the product minus 8. Let's come to the subarrays with size 3. So once again, keep this in mind that the subarrays of length 2 cannot be 2 and 4, right? Because it is not a contiguous subarray. It is just a subset of the numbers. So there is a difference between the contiguous subarray and the subset. So contiguous subarray should be of the contiguous in the contiguous manner. Okay. So let's take the 3 length subarrays, 2, 3, minus 2. So here the product would be minus 12, and 3 minus 2, 4. So minus 24, the product would be minus 24. And finally the subarray with the length 4, which is the product of all these 4 elements. So as you can see, minus 2 is getting included here, so we'll get a negative value which is lesser than 6. So finally we come to a conclusion that the product of the largest subarray, the largest product we can get out of the array is 2, 3 subarray with the product 6. Okay, so now let's discuss another problem. So suppose the input array is minus 2, 0, minus 1. Okay, so let's check the subarrays with product with the single element. So it would be minus 2, 0, minus 1. So answer would be 0 with the single elements. Let's check subarrays with the two elements. So minus 2 into 0 into minus 1, again 0. And finally the subarrays with the length 3, again 0. So finally if we check the largest one, it would be 0. So the result cannot be 2 because minus 2 and minus 1 is not a subarray. So this is the most important concept here. You have been asked to find the contiguous subarray containing at least one number. So you cannot take minus 2 and minus 1. It is not in the contiguous manner. Otherwise it would have been 2 because these two numbers are getting multiplied. Again, if we are talking about the subset, then the simplest way is just to 2 into 3 into 4, which would have been 24, right? So this is the overall problem statement. So even if you have not understood, just take some sample cases of your own to understand this problem in way much detail. But this is the overall problem. You need to take the sub array in the contiguous manner out of the given array, and you need to find the sub array with the largest product. So this is the maximization problem here. So let's discuss some simple logic to proceed with this problem. So first of all, what we can do is we can check all the sub arrays, right? We can check the sub arrays of size 1, which is 2, 3, minus 2, 4. We can keep a track of the maximum product we have received so far. So the product would have been in that case 4, right? 4 would have been the maximum. Then we can start with the sub arrays of size 2. We'll check all the sub arrays of size 2, 2, 3, 3 minus 2, minus 2, 4, and we'll get the product as 6. So 6 is greater than 4, so we'll update our answer to 6. Now we'll check all the subarrays with size 3, and we'll get these 3 and these 3, and finally we'll get a subarray of size 4 and this. So as you can see, finding all the subarrays of a array would be an exponential problem, right? So that's why it would be of highest time complexity. So it is the brute force approach. Like, this is the simplest way we can solve this problem, but answer would definitely be correct in that case, right? So yeah, it is just not good in the terms of time complexity, but answer would definitely be the maximum among all those things. So now the task that we need to think is how to reduce the complexity for this problem. So we'll approach with the efficient approach now. We have discussed the brute force approach. Just find all the subarrays and multiply all the elements within those subarrays and find the subarray with the largest product. That's it. That solves the problem. So the logic that you need to keep in mind is, first of all, we are dealing with product. Okay. So always recall that the product of two negative numbers is positive and the product of two numbers with opposite sign is negative. Let me repeat. The product of two elements having same sign, either both positive or either both negative, is a positive number, and the product of two numbers having different sign is a negative number, right? So this way you can approach this problem. So product is maximum either when a negative value is multiplied to the smallest value or positive value is multiplied to the largest value. Okay, so let me help you understand what I mean by this statement. So suppose you need to maximize the product of two numbers. Okay, so suppose if they both are of opposite sign, so definitely their product would be negative. So in order to make the overall answer largest, they should be of the least possible magnitude. Why? Because minus into plus will always result in minus, and the smaller the negative number is, the larger it is, right? -1 is greater than -2, -2 is greater than -5, and so on. But when the sign is positive, so there is the opposite case. Larger the magnitude, larger is the number. So 5 is greater than 3, 5 is greater than 2, and so on. So whenever you are multiplying two numbers of opposite sign, they should be as small as possible in terms of magnitude, and whenever you are multiplying numbers of same sign, then they should be as large as possible for the largest magnitude. So this is what this statement means. Product is maximum either when a negative value is multiplied to the smallest value or a positive value is multiplied to the largest value. So when you multiply a positive value to a larger value, the overall product would be maximum, right? So how do we solve this problem in the least possible time complexity, which is order of n in this case? So as we know that when we were solving the problem for all the subarrays, it was not a linear time complexity. It was a very complex problem. But now our task is to reduce this to a very optimized way. So we need to take care of the time complexity in this case. Okay. So yeah, let's come to the logic. So suppose if we take three variables, suppose C min, current max, and the overall max. So I'm representing the current min with C min, current max with C max, and the overall maximum value by mx, to store the current min, current max, and the overall max respectively. Okay. So finally we are going to return the max value, because this is the overall maximum product value that we have encountered among all the subarrays. Now let's come to the other logic. So initialize all the three variables to the first element a of 0. So here the logic is very much similar to the logic that we have discussed while solving the problem, which was maximum sum subarray. Okay, so you can check that video out in the description or in the suggestions. So after checking that video, if you come here, it would be very much beneficial for you to understand it in a better manner. So we have solved it in a similar manner. So yeah, let's come to this problem once again. So initialize all the three variables to the first element, which is a of 0. Okay. Yes. So first step would be initialize all the three variables to the first element a of 0. Now we'll make a loop from 1 to n. So we'll loop over all the elements of the array. Now what we'll do, as per the discussion that we had about the logic, the product of multiple numbers can be maximum when the two numbers of highest magnitude are multiplied, which are having same sign, or two elements of opposite sign are multiplied to get the least possible value. Okay, so this is what we are trying to do here. Store the previous value of Cmax in temp. Okay, I'll explain you why we are storing this in temp. Update Cmax as maximum of AI into C minimum, and AI into C maximum. Okay, so why are we doing this? Current maximum can be AI, or AI into C minimum, or AI into C maximum. Now let's understand why these three elements here. So the current element will be maximum because suppose if there is one element which is non-zero, and apart from that all the elements are 0. So in that case, the product would be maximum when that single number is multiplied by itself by 1. Okay, so suppose, let me take an example. So suppose our array is, suppose the array is 0 comma 0 comma 5 comma 0 comma 0. Okay, so in that case, as you can see, the maximum product that we can get with a single element is 5. So in that case, this value will be important, c max of a of I comma a of I into c min into a of I of c max. Now why I am maintaining a track of the current minimum and the current maximum? So let's come to that logic. So current maximum is needed because, as we know, that when a maximum value is multiplied by a positive number, the overall product is maximum. Similarly, when a negative value is multiplied by the most negative value, like the value which is negative with the highest magnitude, in that case also the product would be maximum. So suppose if minus 5 is multiplied by minus 5, the answer would be 25. And if minus 5 is multiplied by minus 1, the answer would be 5. So as you can see, if the two numbers are of highest magnitude and same sign, the overall product would be maximum. Similarly, 5 into 5 would be 25 and 5 into 1 would be 5. So always when the two numbers are of same sign, you need to multiply them with the highest magnitude possible to get the highest possible product. So that's why we are keeping a track of C minimum, which is the current minimum, so that whenever a negative value comes, we can multiply it with C minimum and get the maximum outcome. So suppose the value of C minimum is at current place, it's minus 5. Okay, and the value that comes is minus 5. So you will do minus 5 into minus 5 equals to 25. So as you can see, the overall product that we are getting is the maximum. Okay, and hence we need to keep a track of C max as well as C min, which is current maximum and current minimum. And finally, just update the max value as the maximum among both of these value and return the return that maximum value once the loop ends. So when I'll be writing the code for this, you will understand it in a better manner. So let's dive to the code directly. Okay, so let's initialize an array so that we can test our code. So let's take this example, 2 3 minus 2 4. So vector of int a equals to 2 comma 3 comma minus 2 comma 4. Okay, and as you know, the answer should be 6 in this case. Answer equals to 6, so that we can test our code later on. And let's call the maximum product is equals to this, and let's call find max product with this vector as input. That's it. Now the entire logic will be written for find max product. Now it should return an integer, find max product, and let's take a vector as input. Okay, now our task is to implement this method in order to get the final output. So let's do as we have discussed. So just the logic you need to keep in mind is concept product is maximum when two larger number of same sign are multiplied with each other, or so we'll write a multi-line comment here so that we can incorporate the entire logic within one comment, or when two numbers of opposite sign are multiplied with each other. Okay, opposite sign and smaller in magnitude. Okay, so you will understand when you will take simple examples. So suppose minus 5 is to be multiplied with 2, so it will result in minus 10. And suppose minus 5 is multiplied by 5, so it will result in minus 25. So as you can see, the greater product will be minus 10 as compared to minus 25. Why? Because the numbers are comparatively smaller with the magnitude here. Here it is 2, here it is 5. But suppose if we are dealing with the numbers with same sign, so then that case minus 5 into minus 5 would result in 25, whereas minus 5 into minus 2 will result in 10. So in that case, this is giving us the highest product. Okay, so this is how you need to relate and check for various inputs to understand this logic better. Now let's come to the implementation part of it. So as discussed, let's maintain 3 variables: current min, current max, and overall max. All 3 initialized to the first value of the vector or the array, whichever data type you take, and this. Okay, now let's loop from 1 to n, because we have already handled the first element, so that's why we'll loop from I equals to 1 and not I equals to 0. I equals to 1, I is less than n, I plus plus. Okay, simply first store the value of cmax in temp. Now I'll explain you why I'm doing this. So first take int temp equals to cmax. Okay, why I am storing this value? Because as you can see, we are making use of temp here and not cmax. Why? We should have used cmax here, but we are using temp. Why so? Because as you can see, the value of cmax is getting updated here, but we want to make use of the previous value of cmax, not the updated value. That's why we need to store it in temp, so that once the cmax value is updated here, we can still make use of the previous cmax value to get the overall minimum value. So this you will understand when you write the code on your own, or when you will write it step by step as we are writing here. So suppose we have taken cmax here. Now the task is to just multiply the current number with the current minimum value and the current maximum value. Okay, so that's why we should have used cmax here, but as you can see, the current maximum value is getting updated in the step B. That's why we need to take the previous value, which was the current value before this was implemented. Okay, so that's why the current value will be used here, which is stored in temp. Okay, so first of all, we need to take int n equals to a dot size to get the number of elements in the vector. Okay, now c max equals to maximum among, as it is storing the maximum value, current maximum, so we'll apply the maximum operator. So it will be the maximum among a of I, comma a of I into c max. So this will give us the maximum value when ai is positive, so that positive number when multiplied with the most bigger value gives us the overall product maximum. And finally c max equals to max of c max. So this c max would be the maximum that we have got from here, and the second value would be a of I into c min. Okay, so why c min? Because as we have told, suppose a of I is negative, then multiplying it with the least value would give us the maximum product. So we need to handle all these cases. Many people don't put this condition, and that's why they get the wrong answer. Because if your current maximum value is, as we have discussed here, your current maximum value is minus 2 and your other current minimum value is minus 5. Now if the number a of I is minus 5, so as you can see, when it is multiplied with the least value, which is c min, it is giving us the maximum value. So to handle that case, we need to write this condition. Okay, so it is same as, this step is same as c max equals to maximum among all the 3 values, but we can compare only 2 values at a time. That's why I am writing it in 2 steps, but it is same as c max into c max and a of I into c min. This step is same as these 2 steps. Okay, similarly we need to do for the minimum values, because we need to keep a track of the minimum value as well. So c minimum equals to minimum among a of I, as you have guessed it correctly. Just pause the video for a while and think what should come here and then resume. Okay, so we hope that you have paused it and resume, and now you can continue with the logic. So now we'll follow the same. C min and C min equals to min among A of I, sorry, C min the previous maximum, minimum, and A of I into temp and not C max. Let me repeat, if you will use C max here, then as you can see you will use the current maximum which has been updated, but you need to make use of the previous current max, right? Because it was the value which we haven't updated. That's why we need to store it in temp. So just pause it for a while to understand it in a very better manner, and you will definitely understand it. Just make use of these two simple examples, and it will clear out the case for you. And finally we are storing the overall maximum value in the mx variable. So it would be the max of mx comma, so let's take it maximum among C max and C min, and mx equals to overall maximum comma C max. Okay, so here we are keeping a track of the current max and the overall max. Okay, so let me repeat, the purpose of finding C min, which is the current minimum value, is only to handle the case with the negative numbers, because as I have repeated here, when the least value is multiplied with the negative number, the overall product is maximum positive, right? So that's why we need to keep a track of C min. But while discussing the maximum value, we'll only compare the current maximum, this C max, along with the overall maximum till now, and this is how we'll get the required answer. So let's just return mx here, and let's try our code, then we can proceed further with the other examples. Is 6, right? So okay, just so that it is better in visibility. Okay, great. Now let's take some example with two negative numbers. Suppose 2 minus 3 minus 2 4. So as you can see, as you can guess, the overall product would be maximum when all of these numbers are multiplied. Why? Because when two numbers will be multiplied with each other, it will result in a positive value, and then this positive value with this and this. So let's check what the answer should be. Okay, let me recompile it because we have changed the code. The maximum value is 48. Why 48? Let's check. 2 into minus 3 into minus 2 into 4, and this is equals to, yes, 48 exactly. Now suppose we take one more negative value, minus 4. Now let's check what the product is. So let's first guess what the product should be. If we can take this 2, the product would be 8. If we can take these 3, it would be a negative value. If we take these 3, so it would be 3 into 4, 12. So the answer should be 12. Let's check. Yes, and the answer is 12, in which case when we are multiplying 2 with minus 3 and then with minus 2, so it would be 12. And finally let's take a case with zeros. So minus 2 comma 0 comma minus 1. Here the answer should be 0. Let's check. Why? Because there is no subarray which can be formed without a 0. But let's shift 0 this side, then the answer should be 2 when minus 2 is multiplied with minus 1. Let's check. Yes, then the answer is 2. So this code is running fine for each of the cases that we have discussed. We'll recommend you to go through this code line by line by taking some examples of your own, and you will definitely understand the meaning of the variable we have taken here. So just remember 2 points. Why we are making use of the temp variable, so that we can keep a track of the current maximum before it is getting updated, right? First thing. And second thing, why we are keeping a track of C minimum value, to handle the negative numbers, so that when negative number is multiplied with the minimum value, we result in the positive product as the maximum value. Okay, so we hope that you have understood it. Thanks for listening. Have a nice day.